Hello everyone, welcome to the class. In today's class, we will be continuing solving numericals from study of gas laws. Okay, these numericals are based on Boyle's law, Charles law, and ideal form of gas law. Okay, or combination of Boyle's law and Charles law. So it is the fifth video. This video is the fifth video on study of gas laws. If you have not watched the previous videos, so just you check those videos also. Okay. In fourth video, I had given you some formulas on this Boyle's law, Charles law, and combined form of gas laws, and some relations I gave you, and I had shown you one example based on Boyle's law, one numerical example based on Boyle's law. Okay, so let's continue from that only. It is in page number 119. Questions are in page number 119. Okay, question number 1 we have already done. Now let's check question number 2. Question number 2 says that at a particular temperature means temperature is constant. Okay, a certain quantity of gas occupies a volume of 74 centimeter cube. Volume is given. Okay, so volume, let that be V1. V1 is given how much? 74 centimeter cube at some temperature. Okay, gas occupies a volume of 74 centimeter cube at a pressure of, okay, pressure is also given 760 millimeter Hg, 760 millimeter of Hg. Okay, if the pressure is decreased to, so if pressure is decreased to P2, in second case pressure is how much? 740 mm. That means net decrease is 20. Okay, from 760 it has decreased to 740 mm. What will be the volume of the gas at that same temperature? So volume you have to calculate, V2 you have to calculate. So I'll read the question once again. Okay, if you don't have the book, then just write the question. At a particular temperature, a certain quantity of gas occupies a volume of 74 centimeter cube at a pressure of 760 mm. Full stop. If the pressure is decreased to 740 mm, comma, what will be the volume of the gas at the same temperature? Okay, so given this V1, volume in first case, okay, is 74 centimeter cube. Centimeter cube is the unit of volume that I have already discussed in previous videos. P1, pressure 1 is 760 mm of Hg, 760 millimeter of Hg. Pressure 2, second pressure 2 is 740 mm of Hg. Volume 2 you have to find, the volume in second case you have to find, and here temperature is constant, temperature is kept constant. Okay, temperature constant means you have to use Boyle's law. In Boyle's law, temperature is constant by B-O-Y-L-E apostrophe is Boyle's law. P1 into V1 is equals to P2 into V2. This formula, this relation I have given you. Okay, so P1, put the value. P1 is 760 into V1 is how much? 74 is equals to P2. P2, where is P2? P2 is 740 into V2 you have to find. V2 we need to find. Okay, from here is multiplication sign, so this you take it in the denominator of this and this. Okay, and then you simplify. 760 into 74 divided by 740 is equals to, in right hand side this is already gone this side, so V2 is left. V2 is left. Okay, now you do the cancellation. 0 and 0 gets cancelled, 74 and 74 gets cancelled one time. Okay, so V2, it implies V2 is equals to 76. Okay, Therefore, required volume, REQUIRED, required volume is equals to 76. Unit of volume is this one, centimeter of centimeter cube, 76 centimeter cube. Okay, if you write 76 only, then your marks gets deducted. Suppose if this question is of 3 marks, then you'll get only 2 marks or 2.5 marks. Half marks gets deducted for this unit. Okay, if you have not written the unit, or if you have written the unit some other units, okay, then marks gets deducted. So be very much careful with the conclusion part and the unit while doing numericals, while solving. In mathematics also same thing applies, okay, physics also same thing applies. You will solve, everyone will, most of you will solve the given question, okay, and at the end you will not give the conclusion, or you will not give the proper units. For that, marks gets deducted. And if you have done total 10 questions, if half marks gets deducted from each question, then total 5 marks goes. Okay, so you should be very much careful regarding the units. Okay, next question, question number 3. A student performed an experiment to measure pressure and volume of a gas at a constant temperature and noted the following. Okay, so it is given like this: PRESSUY, pressure in mm of Hg. Pressure is given. Okay, next column, volume is given. Volume in centimeter cube is given. So when the pressure is 100, volume is 80. When pressure is 100 mm, okay, volume is 80 centimeter cube. When pressure is 125, volume is unknown, volume is x. Okay, when pressure is 200, volume is 40, and when pressure is y, volume is 32. When pressure is y, volume is 32. Okay, this is given to you. Okay, calculate the value of x and y. Calculate the value of x and y. You have to calculate the value of x and y. Which law was used in the calculation? Law, this pressure is given, volume is given, so obviously pressure volume relationship is given by Boyle's law. Okay, so Boyle's law is used for the calculation. That is done. Next, draw a suitable graph. For drawing graph, you need a graph paper. So we will not draw the graph. Okay, we will not draw the graph right now. We will solve the numericals. We will find the value of x and y only. Okay. So here, this is the solution. Okay, if you don't have the book, if you are then whatever I dictated, whatever I read the question, okay, you copy that question. Here, P1, pressure 1 is equals to 100. Pressure 1 is 100, volume 1, V1 is equals to 80. When pressure is this, volume is this, and this is pressure 2. P2 is equals to 125, V2 is equals to x. V2 is x. Okay, so let's use Boyle's law. By Boyle's law, P1 into V1 is equals to P2 into V2. This is the formula. P1 is 100 into V1. V1 is 80 is equals to P2 is 125 into V2 is x. V2 is x. So this will go this side. Okay, 100 okay into 80 divided by 125 is equals to x. Now you do the cancellation. 25 4s are 100, 25 5s are 120, 5 1s are 5, 5 1s are 5, 5 6s are 30. So 4 into 16 will be, it implies x is equals to 4 into 16. 4 16s are 64. 4 6s are 24, 4 1s are 5, okay, 64. Therefore x is 64. Otherwise you can write 64 centimeter cube. Centimeter cube, answer. Value of x we have got. Okay. Now next let's find the value of y. In similar manner, you can find the value of y. To find y, we have you can choose these two pairs, this two, or this and this. Any two pairs you can choose. Okay, so I'll use this and this. P1 is equals to 200, V1 is equals to 40, P2, pressure 2 is Y, and here I'll write, okay, below that, V2, volume 2 is 32, this and this I have used, okay. By Boyle's law, BL, full form of BL is, I have just written short form, okay. BL means Boyle's law. By Boyle's law, P1 into V1 is equals to P2 into V2. So P1 is how much? P1 is 200 into V1. V1 is 40 is equals to P2. Where is P2? Y into V2 is 32. Again, same process, you apply 200 into 40 divided by 32 is equals to Y. Do the cancellation. 8 5s are 40, 8 4s are 32, 4 1s are 4, 4 5s are 20, 0. So 5 5s are 20 by 250. Y is equals to 250 and the unit of Y is mm of Hg. mm of Hg. This is your answer. Okay, and below this you write it. Which law was used in the calculation? Boyle's law was used in the calculation. Okay, and graphical portion we will not do right now. Now let's move on to another question. Okay, now next question, question number 4. Question number 4. At a constant temperature, volume of a gas was found to be 400 centimeter cube at a pressure of 760 mm Hg. So volume V1 is given, okay, volume 1 is given, how much? 400 centimeter cube, and pressure 1 is also given, 760 mm of Hg, okay. If the pressure of the gas is increased by 25%, pressure 2 is increased by 25%, find the new volume. V2 you have to calculate, find the new volume, okay. So again I'll read the question. At a constant temperature, volume of a gas was found to be 400 centimeter cube at a pressure of 760 mm Hg. If the pressure of the gas is increased by 25%, find the new volume, okay. So let me write the given things. Given volume 1, 400 centimeter cube, and pressure 1, P1 is equals to 760 mm of Hg. P2 is, if, see, it is said like this, if the pressure of the gas is increased by 25%, pressure is increased by 25%, that means original pressure plus this, P1 plus 25% of P1. Okay, if the pressure is increased by 25%, means whatever is the original pressure plus you have to do 25% of original pressure. And if your question is, suppose if your question is if the pressure is decreased by 25%, then instead of plus sign here you have to write minus, okay. So let's find the value P2. P1 is 760 plus 25% means divided by 100 of is into P2 is how much? P1 is 760. P1 is 760 plus 25% means divided by 100 of is into P1 is 760. Okay, now let me do the cancellation. 25 ones are 25, 25 fours are 100. Here and here you cannot cancel since there is plus sign. Okay, here and here you can cancel because you have multiplication sign. 4 ones are 4, 4 ones are 4, 4 nines are 36, and 4 zeros are 0. Let me check again. 4 ones are 4, 3 is left, 36, 4 nines are 36, and 0. 760 plus 190, it will be how much? 0, 6, 12, 13, 14, 15, 7, 8, 9, 950, 950 mm of Hg. This is the second pressure. Okay, and volume you have to calculate. V2 you have to calculate. Use Boyle's law. Same law you apply. By BL, Boyle's law, P1 into V1 is equals to P2 into V2. P1 is how much? 760 into V1 is how much? 400 is equals to P2 is 950 into V2. You have to calculate. Implies sign. Okay, 760 into 400 upon this will come down in the denominator. 950 is equals to V2. So do the cancellation. 0 and 0 gets cancelled. Let's cancel it with 5. Okay, 5 8s are 40, 5 1s are 5, 4 is left, 45, 5 9s are 45, 19 1s are 19, 19 4s are, let me check, 19 into 4, 4 9s are 36, 3 is left, 4 1s are 4, 5 6 7, 76. Okay, so 40 times. It implies V2 is equals to 40 into 8. 8 4s are 32 and 1 0 is there. 8 4s are 32 and 1 0 is there. Okay, therefore required volume is equals to 320 unit is this one, centimeter cube. This is your answer. Okay, so let's move on to another question. Question number 5. Question number 5 is, a vessel of capacity 600 centimeter cube contains hydrogen gas at a pressure of 330 centimeter Hg. Let's stop. What will be the pressure of gas, a hydrogen gas, when the vessel is connected to another vessel of 300 centimeter cube capacity? So there is a vessel, one vessel is there. Okay, and here its capacity is, volume is how much? 600 centimeter cube, and pressure inside it is condensed pressure of 330 centimeter of Hg. If this vessel is connected with another vessel, if it is connected with another vessel is there, another vessel, okay, of capacity 300 centimeter cube, what will be the new pressure? Okay, so this when it is connected to this vessel, the gas which is present inside this vessel moves from here to this vessel. Okay, and total volume of the gas will be volume of this vessel plus volume of this vessel. You have to, second volume V2 you have to add. Okay, V1 60 plus 300 you have to do. V2 and P2 you have to calculate, because these two cylinders are, two containers are connected. Okay, this is 600, sorry. Okay, so let's do it. Given V1 volume 1 is 600 centimeter cube, pressure 1 is 330 centimeter of Hg. V2 is, you have to add 600 plus one more container, one more vessel is connected with this. Okay, 600 plus 300, because the volume of new container is 300, so it will be 900. And P2, second pressure, you have to calculate. So by Boyle's law, P1 into V1 is equals to P2 into V2. So put the value and solve it. Okay, your answer will be 220 centimeter of Hg. This is your answer. So you complete it on your own. Okay. Question number 6 is, at constant temperature, a gas is at a pressure of 1080 mm Hg. If the volume is decreased by 40%, find the new pressure of the gas. Okay. So here I have written the question. At constant temperature, a gas is at a pressure of 1080 mm Hg. If the volume is decreased by 40%, find the new pressure of the gas. So let me write the given things. Given at a constant temperature is constant, that means you have to use Boyle's law. Okay, pressure P1 at a pressure of 1080 mm of Hg. V1 is not given to you. Okay, if the volume is decreased by 40%, V1 is not given. V2 is, in second case, volume is decreased by 40%. So it means V1 minus 40% of V1 minus 40% of V1. Find the new pressure of the gas. P2 you have to calculate. Okay, P2 you have to calculate. So let this V1 be X. Let it be X. Let the volume, original volume of the gas be X. So from here, put the value V1 is X minus 40, percentage means divided by 100 of is into V1 is X. Okay, so 0 gets cancelled. 2 to the 4, 2 5 are 10. So X minus 2 into X is 2X divided by 5. So do the LCM. 5 is the LCM. 5 into X, 5X minus 2X. From there you will get 5 minus 2 is 3x by 5. This is the second volume. Find the new pressure. P2 is question mark. P2 you have to calculate. Okay, so by Boyle's law, P1 into V1 is equals to P2 into V2. P1 is how much? 1080. V1 is X. V1 we have considered X. Okay, equals to P2. P2 we have to calculate. V2 is 3x by 5. V2 is 3x by 5. So let me erase this part. Below this is 1. Okay, so let's do cross multiplication. This 5 will multiply here, and this 3x will come down, and in right hand side P2 will be left. Okay, 1080 into 3x, 1080 into x into 5 divided by, bring this 3x down. Okay, 3x is equals to, in right hand side only P2 is left. 5 will multiply here, this will multiply down. 3x into 1 will be 3x only. Okay, so x and x gets cancelled. 3 1s are 3, 3 3s are 9, 1 is carried this side. 3 6s are 18, 0s are 0. So P2 will be equals to 360 into 5, 360 into 5. P2 will be equals to 5 0s are 0, 5 6s are 30, 5 3s are 15, plus 3 is 18. So 1800 is your answer. Therefore, required pressure is equals to 1800. What will be the unit? Mm of Hg. Mm of Hg. So this is how you have to solve. Okay. Now let's move on to the numericals based on Charles' law. It is in page number 122. Okay. Okay, so numericals based on Charles' law. So page number 122, page number 122. Okay, number one, question number one is convert the following. Convert the following. Number one, 37 Kelvin to degree Celsius. You have to convert this 37 Kelvin to degree Celsius. Okay, so here K, value of K, Kelvin temperature is 37. C is question mark. C is you have to calculate. Okay, and our relation, I had already given you the relation in the fourth video. We know K is equals to 273 plus C, or C plus 273. Okay, so put the value of K. K is 37 is equals to 273 plus C. C you have to calculate. So this goes this side. 37 minus 273 is equals to C. So subtract it. 273 minus 37. So 13 minus 7 will be 6. 6 minus 3 is 3. 236. C is equals to okay, I'll write like this, minus 236 is equals to C. This is bigger, so I have to write the sign of bigger number. Okay, so minus 236 equals to C. Therefore, you have to write the conclusion. 37 Kelvin is equals to minus 236 degrees Celsius. You have to write this. Therefore, 37 Kelvin is equals to minus 236 degrees Celsius. While expressing the temperature in Kelvin scale, don't write degree. This is mistake. Okay, 37 degree Kelvin. Don't write degrees, this symbol of degree. But if you write like this, 236 Celsius, then this is mistake. If you are expressing the temperature in Celsius scale, then you have to put degree, this symbol of degree. Okay, so keep this in mind. Next question is 273 Kelvin 2 degrees Celsius. Number 2 is 273 Kelvin 2 degrees Celsius. So here K is equals to 273, C is equals to question mark. So we know K is equals to 273 plus C. K is 273 is equals to 273 plus C. C you have to find. So take this side, 273. When this goes towards left hand side, it becomes minus. Okay, 273 is equals to C. So 0 is equals to C. Therefore, 273 Kelvin is equals to 0 degrees Celsius. In Celsius, you have to put the symbol of degree. Okay. Let's move on to another question. Okay, next, number 3. Question number 1. Sub number 3 is convert minus 27 degrees Celsius to Kelvin. Okay. So here, value of C is given minus 27. No need to put degree right now. Okay, K is question mark. So we know K is equals to 273 plus C. K is equals to 273 plus C. So K you have to calculate. K is unknown. Okay, 273 plus put the value of C. C is how much? Minus 27. So K is equals to 273 plus minus 27. So K will be equals to, subtract it, 273 minus 27 will be how much? 13 minus 7 is 6. 6 minus 2 is 4. 2. Okay. 6 minus 2 is 4. 246. K is equals to 246. Therefore, you have to write the conclusion. Minus 27 degrees Celsius is equals to 246 K. 246 Kelvin. K stands for Kelvin. C stands for centigrade or Celsius. Okay. So don't put degree here. Okay, be careful with this. Don't put degree Kelvin. While expressing temperature in Kelvin, you have to put K only, okay? And K should be in capital letter. This one, this you try it on your own. You follow the same process, okay? Whatever is done here, you follow the same process. Instead of this minus, you have plus. So here it will be plus 27, and 273 plus 27, how much you will get? Okay, that will be the answer. Okay, next let's move on to question number 2. Okay, so your question is question number 2. Okay, 20 ml of hydrogen. 20 ml. Ml means unit of volume, so this is V1. Okay, 20 ml of hydrogen gas at, this is T1, and in previous video I have said that always convert the temperature in Kelvin scale before doing the calculation. Okay, while using Boyle's law, Charles law, combined form of gas law, always keep the temperature in Kelvin scale. So this one you have to convert to Kelvin scale. Okay, T1 is heated to this one, this is T2. Again you have to convert this to Kelvin scale at constant pressure. Constant pressure means you have to apply Charles law. Okay, find the new volume. V2 is question mark. V2 is question mark. So let's write the given things. Given V1 volume is 20 ml, milliliter. Okay, gas T1. T1 is minus 13 degrees Celsius, and this will be equals to minus 13 plus 273. You have to add 273. Okay, in order to convert Celsius to Kelvin scale. So it will be how much? Minus plus you have to subtract. Okay, 3 minus 3 is 0. 7 minus 1 is 6, 260, and sign will remain plus. Temperature is this 260, and T2 second temperature in second case is 117 degrees Celsius. So it will be 117 plus 273. In Kelvin scale you have to convert. Okay, always keep the temperature in Kelvin scale. Okay, 7 plus 3 is 10, 7 plus 1 is 8 plus 1 9, 2 plus 1 is 3. Let me check here also. 273 and 117, 10, 7, 8, 9, 2 plus 1 3, 390 Kelvin. You have to calculate volume. V2 is question mark. V2 is question mark. So we use Charles law. Okay, by Charles law. Why we are using Charles law? Because pressure is